What's up guys, welcome back to the channel. In this particular video I will explain the problem find first set bit. This problem is quite easy and interesting, and guys this problem is based on number systems, so make sure you stay tuned till the end of the video. Starting with the problem statement, so it says that you are given an integer n. The task is to return the position of first set bit found from the right side in the binary representation of the number. One note is given here which says that if there is no set bit in the number, then you can return 0 from the function. One example is given here guys. Let me explain the problem with the given example. So we have a number 18, right? What is the binary representation of the number 18? So we have 01001, right? This is the binary representation, and if I start from the right side, then what is the position of the first set bit? Set bit is basically the bit which is 1, right? So the position of first set bit is 1 2, so we have to return 2 as the output, right? We will start counting the position from 1, then this is 2, this is 3, this is 4, this is 5, and you can see that this is the position of first set bit in the number. So 2 is going to be the output for this particular example. Now guys, I hope you are clear with the problem statement. Let's talk about this solution now. Okay, so I have written one example here, and guys, in order to understand the approach, first we need to understand how we convert a simple decimal number into its binary form. So let me write here decimal to binary, right? Let me write here. Okay, so see guys, what we do is we generally keep dividing the number by 2, because a binary basically means that base 2. Binary means that base 2, so we will simply keep dividing the number by 2 and we will keep track of the remainder and quotient. Let me explain how it works. So first divide the number by 2. I will have quotient as 20, right? And remainder will be 0. After this I will again divide this number by 2. Then I will have remainder 0 again and quotient as 10. Then again divide this number by 2. So I will have quotient as 5 and remainder as 0. After this again divide this number by 2. So I will have remainder 1 and quotient as 2, isn't it guys? After this I will again divide this number by 2. So now the remainder is 0 and quotient is 1, right? So again I can divide this number by 0. So I will have 2 and then I will have 0 here. And after this guys, what is the remainder? So 2 1, then 2 0 times 0, then remainder is 1, right? So 1 is the remainder. And now let me first erase this. What is the binary form? So guys, this particular number is going to be the binary form. I have to start writing from below. So I will have 1 first, then I will have 0, then I will have 1, then 0 0 0, right? Or if we start writing from the right side, so I will write from up to down manner. So I will have 0 first, then 0, then 0, then 1 0 1. So this is how we convert a simple number into its binary form. Now guys, I want to write the code for this. So see, while my number is not equal to 0, because this is my number, and at last point you can see that when our number becomes 0, so I have to stop. So if you have n, then while n is not equal to 0, I have to keep dividing the number by 2, isn't it? I simply keep dividing the number by 2. N equals to n divided by 2. But before that, I want the remainder, right? I want the remainder of 2 divided by 40 divided by 2. So I'll write that remainder, or remainder, or it is a current bit, right? So it is better to write bit here. So my remainder or the bit is going to be bit is equal to n, then mod, then 2, right? This is going to give me the remainder and this is going to represent the bit, right? So this is the position from the right. You can see that this is the rightmost bit, then this is the second rightmost bit. This is how we are going to move, and this is the leftmost bit, right? So guys, see, this is how I can get every bit here, isn't it? So I just need to check if my bit if my bit is double equal to 1, then we can get our every one bit, right? Or every set bit, and we want to get the first set bit. So here, whenever our bit we get a set bit here, so we have to simply return, right? Return, but we have to return the position. How we can get the position? So I'll say that okay, initially my position is equal to 1, right? After this, what I can do is I can simply increase the position every time I move to next bit. For example, this is the first bit, then when I move here, then my position will increase and it will now point to second position, right? Then it will point to third position, then fourth position, and you can see that at fourth position I have bit equals to 1, so I'll simply return position here. But if this loop is completed and we have not returned position, like we have 0 0 0 everywhere in the binary form and we don't have 1, so we are simply going to return 0 in that particular case. So I'll write here return 0 if the loop is completed and we have not reached this particular condition. So guys, this is the whole idea behind the solution. I hope this particular idea is clear to you. But if you have understood this particular approach, I have an interesting optimization here. See, for an odd number in binary representation, we always have the rightmost bit as 1. So whenever we have an odd number, then we are simply going to return position 1, right? For example, see, this is 40, and if I want to convert this 40 into 41, so what I'll do is, what is the binary form of 40? This is the binary form of 40, so I'll simply make this 1, right? This is how I can convert, and now you can see that for odd number I have got this bit as 1. Similarly, I can convert like, we have to observe this particular thing, that binary form of odd number always have 1 as the rightmost set bit, right? So guys, see, whenever I have, if my n mod 2 is equal to 1, then I can simply return position 1. This is the observation, and now guys, this is the whole idea. Talking about the time complexity, so we have a number n and we keep dividing the number by 2, right? So we have n, then n by 2, then n by 4, then n by 8, like this, right? So guys, see, at last it will become 0, and whenever we add this particular series, so the addition of this particular series is log n base 2, right? So log n is going to be the time complexity, like how many times I'm going to perform this particular operation. So the answer is O of log n, right? This is the time complexity. Talking about the space complexity, so space complexity is nothing but O of 1, right? Now guys, I hope you have understood everything related to this particular problem. I'm just left with the implementation. So let me show you the implementation in C++, Java and Python. So this is the implementation in C++, and now guys, this is the implementation in Java and Python. You can see here that the idea is quite simple. First we have position variable, then we are simply going to convert or iterate over each bit, and whenever our bit becomes 1, then I can simply return the position of first set bit, right? And this is the same code I have written here, and this is the Python code, right? Now guys, this is all about this video. Thank